Welcome back to more on conics. We are going to talk about hyperbolas today. Specifically, we're going to know how to recognize an equation of a hyperbola in standard form and how to graph a simple hyperbola. We'll do more another day, so that's all we're going to do for today. Let's move on to something you did in class with your partner. You had this clay model, and you put your two cones together, created a cross section with the base on both ends, and when you did that, you have a hyperbola. This is a vertical hyperbola right there, and we have a horizontal hyperbola over on the left, going left and right, and those are the two types of hyperbolas that we'll be dealing with. I want to introduce some of the characteristics of a hyperbola. Specifically, let me move this box over and reveal something you already know. You already know about the vertex and the focus, and those are all characteristics of a parabola, and they also are introduced into hyperbolas as well. So let me reveal the rest of what we have and show you some things that are new. Okay, do you see anything on these graphs that look new to you? How about this word right here, transverse axis? That's going to be this right here. This is a horizontal transverse axis for obvious reasons because it's going in the horizontal direction. And this right here would be, can you guess? You're right, it's vertical. So when you have a transverse axis, it will actually cut through the hyperbola. Keep that in mind when you graph because that will be a key factor in helping you to know which way your hyperbola is going to open. So once again, the transverse axis is kind of like your major axis in an ellipse. It's the one that's going to follow the form of your figure. The other thing we have here is we have some asymptotes, which we already graphed in different lessons, but we're back with them in hyperbolas, and the reason why they're here is to help guide the shape of the hyperbola. Remember, when it comes to asymptotes, the goal is to draw it such that you come real close to the hyperbola, but you don't let that hyperbola cross over the asymptote line. Okay, so the other things I want to point out is unlike an ellipse, the hyperbola is going to always start with a squared, always. So the a term leads in hyperbolas, and I've highlighted those in the middle of your diagram. And just a recap at the bottom here, horizontal, a squared is under the x value. In a vertical, you're going to have your a squared under the y value. So a squared under the y value is going to be vertical. We have asymptotes, b over a for horizontals, a over b for verticals. No need to memorize that. We're going to find a way to do that so we don't have to memorize. Okay, let's get started with our first example. All right, so we have x squared over 4 minus y squared over 16 equals 1. This is standard form because equals 1, just like an ellipse, tells us we're in standard form as long as the x squared and the y squared have no coefficients in front of them. And they do not, so we are in standard form. We've been asked to do 4 things. We've been asked to find the vertices, the foci, the slope of the asymptotes, and then graph. To do that, we need to find some parts of the hyperbola. And just like in an ellipse, we are going to have to find our a, we need to find our b, we need to find the c, and I think it's a good idea to always know your h and your k. Okay, so let's find our a. A is always the leading term, always. So a is the first one right here. It's the square root of 4. So a is 2. For b, square root of 16, b is going to be 4. And for c, unlike the ellipse, we are actually going to add the a squared plus the b squared and take its square root. So this is straight up Pythagorean's theorem. Our h and our k are 0, 0. Let's go ahead and start plotting things, and then we'll be able to find our vertices, foci, and asymptotes. So if 0, 0 is our starting point, let's go over to this a equals 2, and it's under the x value. So if 2 is under the x value, then I'm going to move right and left. I'm going to go 2 to the right, and I'm going to go 2 to the left. These two dots right here, I'm going to mark with a V. Those are our vertices. Let's figure out where they are on the graph and write them in our blank line. We can see that they are 2 and 0 and negative 2 and 0. It's okay if you go ahead and just write plus minus 2, 0 from now on. If you'd like to shorten that up, one way that you can do it is to say that you have a positive and a negative 2, so you can just write it as one ordered pair with the plus minus there. The plus minus is important, so make sure you include that. Let's go ahead now and graph our foci. Our foci is going to be when we take our value of h and add c. Well, we got to find c first, so let's go ahead and find c. C is going to be square root of, well, a squared is 4, and b squared is 16. Did you notice that we just took the denominators? That's all we really did. And so you have the square root of 20. So c equals the square root of 20. We can go ahead and use our calculator for that, and that's approximately 4.5. So what do we do with that 4.5? Well, we'll start with the HK location 0, 0, and we're going to count 4.5 spaces to the right, and we're going to plot that foci right there. I'm going to mark it with an F so you're clear that that's the foci. And I'm going to go over to the left, 1, 2, 3, 4.5. Mark that with an F, and that's my foci. What would I do if I were actually going to write the ordered pair? Well, I have 4.5 to the right, 4.5 to the left, and so it would be a negative 4.5. And I can go ahead and put a plus minus here, and with a comma 0, and there's my foci, plus minus 4.5, 0. Now, to get to the asymptote, what we're going to have to do, I'm going to create a box, and that's going to help me to draw some asymptotes and the parabola. So what I'm going to do is I'm going to look at this B. And I'm going to take the B, and since it's under the Y, that means I'm going to go up or down. And so I'm going to go up 4, 1, 2, 3, 4. I'm going to put a dot right there, and I'm going to go down 1, 2, 3, 4. Now what we want to do is we want to create a box encompassing all the dots that we just put down here, the blue and the green dots, and make a rectangle. So go ahead and do that with me. You're just creating a rectangle. Almost there. Okay, so we have that rectangle there, and that's going to help us draw the asymptotes. The asymptotes are going to go through the diagonals of the rectangle, and I'm going to show you that right here. I'm going to pop that up on the screen. Watch how it goes. There we go. So the asymptotes go through the diagonals of the rectangle, and that is how we get our slope. And what our slope is, of course, is rise over run. So let's go ahead and see what our slope is. If we rise 1, 2, 3, 4, and run to the right 2, that would give us our slope. So our slope is going to be 4 over 2. Which equals 2. Now you have two slopes. You have the one that I'm going to follow along with the pen here. It's going up from left to right. That's our positive slope. And I have another one going down from left to right, and so that's our negative slope. So you always have two slopes with hyperbolas. So we're going to say plus minus 2. Because of course if we went up 4 and to the left 2, that would be a negative 4 over 2. Or negative 2. So our asymptotes are plus minus 2. All we have left to do now is to graph the hyperbola. So let's get started with that. Now we're in an x equals, so that means that we're going to go left and right. I'm sorry, I didn't mean to say x equals, but we start with an x. X is the leading term. So if x is the leading term, then we're going to go left and we're going to go right. So here we go, starting at the vertex. I'm going to swing my parabola over, try not to hit that asymptote. That's one direction. Let's go down the other way. There we go. And that's one side of the hyperbola. Let's make the left-hand side. Swinging around that way and finishing it off and hugging close to that green line, but trying to avoid hitting it. And there you go. That's our first graph of a hyperbola. So once again, to get started, you always want to make sure you find A, B, C, recognize your H and your K. The rest of the information we will get by graphing. Okay, in this next example, we have to do the same thing again. We're going to find all four pieces, vertices, foci, slope of asymptotes, and we're going to graph. And I want to point out to you something. I'm not sure if you've seen this yet, but now this time we're leading with y. That means that our parabolas are going to go up and down. First thing we want to do is we want to establish our a. So let's take the square root of 16. Remember, a always leads. So a equals 4. It looks like our b is 3. Let's go ahead and find our c. We find our c by adding the denominators. Let's just put those together. 16 plus 9. I'm going to write that out for you so you can see how it works out. 16 plus 9. And you get the square root of 25, which of course, square root of 25 is 5. And what's our h and our k? Our h is 0. Our k is 0 because we have no h or k in our problem. All right, vertices. Well, let's plot that 0, 0 first. There we go. And our a is under the y, so to get our vertices, we're going to go up 4. 1, 2, 3, 4. How did I know to go up? Because look at that 4, the a, it's under the y's. Y's move us up and down. So let's go down 1, 2, 3, 4. So this is a vertical hyperbola because the transverse is vertical. Our foci and our vertices always sit on the transverse axis. Our foci is going to be the same thing, only instead of counting 4, since our c is 5, we're going to count from our hk, we're going to go up 5. So we're just going to go 1 past that blue dot. And same thing underneath, we're going to go 1 past it, and those are our foci. I'll label that F so that you know that these are the foci. Okay, so now what do we have left to do? We have to work with that 3 over there, and we have to create our box. So let's go over and grab a color so we can go ahead and map out 3 to the right. There it is. And 3 to the left. There we go. Now you can see that I'm creating a rectangle here, and I'm going to reveal that box. And now I'm ready to go ahead and record all the information I need. So let's start with the vertices. On the vertices, they are in blue. And what do we have? We went not left or right any, we went up 4. So it looks like our vertices are 0. Let's go ahead and make this a short version, plus minus 4. Our vertices in red went up 5, down 5, so they are 0, plus minus 5. So as you can see, plotting everything and figuring it out, just working it off your graph is the easiest way to graph hyperbolas and get your information. Asymptotes are slopes. So how much did we go up from this HK to the vertex? We went up 1, 2, 3, 4, and over 3. Up 4, over 3. So our slope is plus minus 4 over 3. All we have left to do now is to graph. Remember, if y is leading, hyperbolas are going to be up and down. So here we go. We're going to swing this around, hit the vertex, come on back, try not to hit that line. And down here, we'll do the same thing. We're going to start with the vertex, swing it around. And there we go. Those are the graphs of our hyperbola for example 2. Example 3. We have 4 examples total today. Let me back that up and get back to 3. There we go. So finding the vertices in this particular example require us to do just a little bit of work. Nothing much going on here. We have to get that to a value of 1, just like we did with ellipses. So we are going to have to divide out that 900. So recognizing again that we're not in standard form, we're going to divide out the 900. So let's do that. Okay, we're going to do it to every term. And what are we left with? Let's take a look at what we have. We have over here, just making some room there, we have 36 divided by 900 would give us x squared over 25 minus y squared over 36. You can use your calculator if you're not sure of these numbers. And of course, 900 divided by 900 is 1. There we go. Okay, so our A is going to be 5. Let me go ahead and show you the square root of 25 is 5. Square root of 36, 6. Our C is going to be the square root of, let's add that 5 and 6 together, and we will get 25 and 36. Let's add 25 and 36 together, and we get 61, which is approximately, if we go to our calculator, 61 is approximately 7.8. And our H and our K are 0 and 0. Now this graph will be a little bit easier if we go in intervals of 2, because the 5 and the 6 are going to kick that box way out too far, and we won't even be able to get the hyperbola on the graph. So go ahead and mark intervals of 2 here. Let's graph the A, which is sitting under the x. So if A is sitting under x, that means I'm going to go to the right 5. So 2, 4, and 5 would be halfway between. That's our vertex. And I'm going to go to 4. Here's our vertex here. Let's go ahead and graph that 6 for B while we're in a graphing mode right now. And the 6 is going to go up 2, 4, 6. So plot my green dot there, down 2, 4, 6. There we go. And let's make our box. I'm just going to reveal mine here. There you go. You go ahead and do the same. Get that on your graph. Okay, so let's go ahead and give the information that we know. The vertices are going to be plus minus 5, comma 0. The foci, we need to plot those yet. We are going to go 7.8 plus minus 7.8. So 2, 4, 6, a little almost on the 8, and 2, 4, 6, not quite on the 8. Those are our foci, and so we'll go ahead and say plus minus 7.8, comma 0. And let's see what our asymptotes are. Remember, we're in twos, intervals of 2, so we're going to count 2 as we go up and 2 as we go over. So 2, 4, 6, and 2, 4, 5. So our asymptotes plus, minus 6 over 5. All right, very good. We're almost done. Let's just graph this. What kind of shape is this? Oh, x is leading, so it's going to go left and right. We know that because our foci always has to be inside also, so there's 2 ways we can look at that. Let's go ahead and graph, and we're done with example 3. And then we will move on to example 4. I hope you did better with your parabola than I did with mine just there. Okay. There we go. All right. I'm sure yours is much better than mine. There we go. All right, last one. Okay, in example 4, we are in standard form. The only difference here is we now have an h and a k. So instead of working from 0, 0, we're simply going to plot our points working off of whatever h and k are. Now the trickiest part, too, this particular example is knowing who's h and who's k. So I want you to look at that. I'm not going to say anything for a few seconds, and you think about who's h and who's k. Now remember that k always goes with the y value, so it's actually the 3 that's the k, and the -2 that's the h. I said the opposite signs because we know when we take them out, they're the opposite signs. So the starting point is going to be -2 and 3. That's where we're going to start. So let's go ahead and plot that. I have it on the graph already, -2, 3. Go ahead and do the same. So starting with y means that this is going to be a vertical hyperbola. So our hyperbolas are going to be up and down. Let's compute our a. What's the square root of 1? That is 1. Square root of 9, 3. Our c, we're just going to add the 1 and the 9, and we get approximately 3.2. Okay, so let's start plotting from this orange dot that you see on the graph. So if A is underneath the y, that means I'm going to go up 1, and I'm going to go down 1. And for the B, I'll go to the right 3, and to the left 3. Then I want to box that off, and when you do that, you should have what I have on mine. Go ahead and see if you can catch up to me. And now let's go ahead and plot our foci from the orange dot again. We're going to go up how many? 3.2. So up 1, 2, 3, and just a little bit past that. And then the same thing going down, 1, 2, 3, and a little bit past that. There you go. Now let's go ahead and record what we know. Our vertices, where are they sitting? Just follow the graph again. So we go to the left 2, so -2, and up 1, 2, 3, 4. So -2, 4 is going to be our first one. That's our first vertice, -2, 4. And for our second one, -2, 2. That was pretty easy, wasn't it? All you have to do is work off your graph. Let's go ahead and do the foci. We have -2, and how far up did I go? Let's count them together. 1, 2, 3, 4, 5, 6, and of course that 0.2. And then the other one we have is -2, and -0.2. I'm going to put a 0 in front of that, 0.2, because it just is a little bit underneath that x-axis. if we were 1, 2, 3.2, it's just that 0.2 that's left over. So that right there is a 0.2. I'm going to erase that so you can see it better. So this coordinate right here is 0.2. There you go, that's better. And for the asymptotes, let's take a look at our vertical rise 1 and our run is 3. So it looks like our asymptotes are plus minus 1 over 3. And all we have to do now is graph, and we're going to start at that vertex, swing it out both directions, and that, I believe, is our last example. Let's flip and see what we have left. So once again, I just want to recap before I do flip on the fact that you establish your HK, and once you do, plot it, that orange dot there, take your A, it's underneath the Y, so underneath the Y tells you to move up 1, down 1. Your B, 3 is underneath the X, so that means you're going to go to the left 3, to the right 3. Your foci, 3.2, from the orange dot, go up 1, 2, 3.2, and go down 1, 2, 3.2. Okay, let's see what we have left. I think we're going to wrap it up, and yes, we are. So unlike an ellipse, A is always first in a hyperbola. Let's write the word hyperbola there. That should finish that off. In an ellipse, there's a plus sign, but in a hyperbola, we have a minus sign. H is always with the X, K is always with the Y, be aware of that. And in an ellipse, when we look for C, you're going to actually do a minus, and for hyperbola, we're going to add, and of course, those are both square roots. Okay, well, we'll see you soon, and good luck with that worksheet tomorrow. We'll do it together.